transition it.
Okay, you
Oh, yeah,
can
we're
see
fine.
your head and everything else.
We are going to be talking about electricity. So, electricity.
Can you start over again?
What?
Can you do the intro one more time? Sorry.
What happened?
Didn't transition.
Did they hear us though?
Cool. Good rehearsal.
Go for it, yeah.
Hey everybody! Welcome to another AstroCamp LiveLab. My name's Caity.
My name is Scott.
Alex is in the back doing all the technical stuff.
Hey guys.
But we are bringing electricity to you today. We transitioned over to YouTube. So we're really excited to bring that to you. If you have any questions, comments, concerns, please leave it in the chat. We want your feedback. We want to know what you guys want to know about the demonstrations we're doing. I'll be your moderator, so I'll be checking out everything you say. And yeah, it's going to be a good time. So let us know what you're feeling as we're doing our demonstrations.
Heck yeah.
Yeah.
Let's do it.
Let's go!
Okay, so like I said, my name is Scott. I'm going to be your ambassador to science today. So the first thing we're going to talk about is, what is electricity? Now there are three parts to the atom. There's the proton, the neutron, and the electron. Now of those three, it's pretty obvious which one has the most to do with electricity, as far as we know it. It's the electron. Now that's not to say that the other parts don't have anything to do with electricity, but when we're thinking about electricity flowing through a wire, those are the electrons moving. Now, we measure electricity in a couple of different ways, and you've probably heard them. One of the ways that we record it is via current. The other way is via voltage. These things are hard to understand. Even for people like me who went to school for physics and learned about it, it's hard for me to understand. That's why we have a demonstration using water. I know I said that as if it was really, really cool, but water is really cool. We can measure electricity and the current of it based off of how much water is flowing. A low current would be something like little tiny drips of electricity flowing through the wire. Whereas a high current would be something like this. Tons of water flowing all at once. That sort of makes sense, right? The amount of electrons that are going through an area at any given time is how we measure current. But the way we measure voltage is actually a completely independent thing than current. So whereas current was the amount of electrons going through, voltage is how far the electrons are flowing. So a low voltage might just be like very, very close, whereas a high voltage might be, oh, I just spilled it all over the table, oh great, is really, really far like that. We can combine these different amounts of current and voltage. So, we could have a really high voltage, but still very low current. Or we could have a low voltage, but still a lot of current. But whenever we have both, I'm not going to even try this because I've already spilled a bunch on this table, which, we're talking about electricity is super safe to do. If we had a high voltage and a high current, we would have something called high power. Power is the multiplying of voltage and current together. Most of the devices that we use are pretty low power because they either have a low current or a low voltage or both. But when we have high of both, we have incredibly high power. The device that I'm going to be showing you guys today is a low power device. Therefore, I'm not going to hurt myself or anybody else who's in our studio with us today. Okay, so getting started, you guys have definitely heard of conductors and insulators, right? A conductor is an example of a material that can take electrons and allow them to pass pretty freely through them, aka copper wire, gold, water, you've heard. An insulator is the opposite. It's something that says to the electrons, no, you can't pass. And therefore, the electrons don't go through that area. Examples of good conductors are things like metal. You can see right here, and by the way, I just picked up this thing right here. This thing is known as an Uden coil. It builds up a static charge up here, and we can see how the electricity flows from some objects to others. So I'm going to show you guys what it looks like when we flow something to a conductor. Okay. If we can get our studio lights, we can turn those off and give you a good show of this.
What happened? Hold on, guys. We have something weird going on.
Ooh. What's happening?
Did I do something? Oh, we're good. We're fine.
Okay.
We're
Sweet.
good.
Okay. We're doing okay. Bear with us with these new technical difficulties. Anyways, we can zoom in on our device right here, and we can turn off the studio lights. And when we do that, we can see the electricity flowing pretty well. Okay, we should be back now.
Yeah.
Oh, okay.
Wait, good guys, can you hear us now?
Yeah. Also, there's a stream delay, so you won't be able to comment on anything for a little bit.
We're fixing the sound is what I'm
Yeah, I
writing
put
down.
it in the chat.
Okay.
Yeah.
Cool.
Fantastic. Yeah, comment if you can. Yeah, sweet. Okay, fantastic.
Yeah, thank you guys for being so patient. We're new to YouTube, so yeah. Thanks for being our guinea pigs.
Man, here's an audience who knows how to be patient. Anyways, why don't we pick up from a couple of seconds ago, where we're talking about the conductivity of different objects. Metals and water and other kinds of things are good conductors of electricity, but things like rubber are not. So why don't we turn off the lights? We can adjust the stuff and we can see. Yeah, nothing. There's pretty much nothing going on with that. But that being said, balloons still can create static electricity. Let me know if you've ever done something like this before, right? Where you rub a balloon up against your hair and it sticks to it. It's crazy, right? This is actually happening due to static electricity. As the rubber rubs against my head, against my hair, it builds up a large charge of electrons on the balloon, which means it has to take them away from somewhere else, aka my hair. And I don't know if you guys have ever heard of opposites attracting, but positive charges and negative charges come together, whereas two negative charges are going to push away one another. So I don't know if you've ever seen anything cool like that happening, but that's the reason why that stuff happens. Now, continuing on with this Uden coil, as you can see that there is like this purplish color that happens. We can do another shot of this right here. So let's get the studio lights. Okay. Just like that.
Alright. It looks like our Uden coil is causing some problems with the sound, or with our microphone.
Yeah, so, one downside that we, didn't really think about, lightning that happened. So when you see lightning striking, we can actually have the electricity up in the clouds coming down to the earth via the air, turning the air temporarily into a wire. And when we see the electricity going from one end to another, that's what we're actually seeing, especially on this Uden coil as well. Now, if for some reason I was holding onto the Uden coil, and bear with us, we might lose sound again, and if that happens, we can try and fix it. Just let us know if there's no more sound, and we should be able to see if there's no audio bars happening. But I'm going to hold directly onto this Uden coil. Now, it does have this big warning sign, but I don't care. good conductors. No more sound?
No more sound.
No more sound. Oh, should we get now?
Cool.
1 second. I'm switching it back to the snowball now.
Oh man. I can't believe it's that
Okay,
Yeah.
we're back.
Yeah, our microphone is so incredibly sensitive. It's so high tech that we lose sound every time I turn on this device. So maybe we will just do the rest of this lesson completely silently. But either way, we're going to have fun. Holding onto the Uden coil is fine because it doesn't have to go through any of the air. It doesn't have to ionize the air molecules, which makes them really, really hot, which makes lightning very dangerous. However, electricity moving through the body is not always safe. Because this is a low power device, it has a low voltage compared to its high current, it's not going to do any damage to my body. But another device, such as a Tesla coil, if you've ever heard of something like that, has both a high power and a high voltage. Well, high current and high voltage, which means high power, which means that it has the potential to hurt the human body. Our brain communicates with our muscles via electrical signals. As these electrical signals move to our muscles, it says, make a thumbs up like this. However, our heart is also a muscle. If an electric signal that's not coming from our brain reaches the muscles in our heart, it can cause it to go into arrhythmia, giving you a heart attack or stopping your heart entirely. So thank goodness this device is not very high power. You know what, guys? We're going to risk turning this microphone off again. So I'm going to say everything beforehand, and then we'll do the experiment. So the experiment is, the human body should be a good conductor of water, of electricity, because it is filled with about 70% water. And because of that, I should be able to pick up a light bulb like this, one of these fluorescent light bulbs, and have it light up entirely. So what we can do is we can turn off our studio lights.
Our
can zoom in.
Everything.
And turn off everything but the cameras and show you this cool trick.
Okay, and then switch it back. Bam.
Cool.
Okay, we're back.
Sweet. Just to let you guys know, on the technical side of things, we're having to restart our microphone after every time we turn on this Uden coil. Crazy, right? You think we would have come up with something better by now, but we're doing the best that we can. But you guys saw that this light bulb was turning on. The electricity, as it flowed through my body and came through my hand to this right here, the electrons from my body repelled the electrons inside this tube light. And the movement of electrons is electricity, which causes the device to turn on, which is, to say that maybe I am Thor or Zeus or, I don't know, maybe Tesla or someone else cool like that. Now, other experiments that we can do with this Uden coil without turning it on are very limited, so we're going to have to turn it on again. But this time, we can show you guys the different colors of lightning. So lightning is a very purple color in our atmosphere. And I see that we have a quick question.
We do, from Bryce.
Oh, yeah?
Does lightning go from the ground to the clouds, or the clouds to the ground?
So I've heard both ways, and honestly, it depends on where the charge is being built up. If it's being built up in the clouds themselves, it might travel from the clouds down to the ground, or if the opposite charge is being built up in the clouds, it might travel from the ground upwards. If you see any slow motion videos of lightning, sometimes you will see it appear to go from the ground up, but that's not always the case. That's a good question. Anyways, the color of lightning, right? We saw this sort of violet purplish light. And if you've been tuning in with us for our previous Instagram videos, then you'll know that different gases, when electricity flows through them, lights up different colors. So the gas around us right now is a nitrogen-oxygen mix with a small amount of carbon dioxide and argon and blah, 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 blah. But if we take that environment and we turn it into something entirely different, such as carbon dioxide, and I can do that by depositing some dry ice into this tub right here. It's very cool. By the way, if you've never seen dry ice, it's very cool, literally. Negative 109 degrees Fahrenheit. Okay, we're going to try this again, and after we're done, and if you don't hear any sound, just see me smiling at you, just know that our behind the scenes people are trying their best to get the audio working back again. But for right now, we're going to turn off the studio lights and try and show you guys a different color of gas. The lightning and the radio electro. I don't know. I'm just making things up. Welcome back, guys. You can hear me again. Oh man, isn't this a fun time that we have to be doing this together? But you can see that in a different gaseous environment, such as carbon dioxide, you can see that the electricity is a different color. That's because as the different gases are ionizing, they let off different colors of light. In carbon dioxide's case, this bluish color. In our atmosphere's case, more of the purple color, which is pretty cool. Now, do we have any other questions? There's not a whole lot of stuff that we can do with the Udon coil without breaking our equipment. But if you guys have any suggestions of things that you want to see shocked, we can always take those from the audience. And in the meantime, I can show this to you right here.
How does that work?
I explained it earlier, but I don't know if the microphone was on or off. But these balloons, as they rub against something, they actually transfer electrons from one object to the other. I'm actually unclear if it's from the balloon to my hair or from my hair to the balloon, but either way, we get a net positive or negative charge on the balloon, and then vice versa on my hair. And like I said, opposites attract, so a positive charge and a negative charge will go towards each other and sort of stick to one another. Anyways, well, I have maybe one last thing that I want to show you guys if you want to ask any questions, and that's just like what the electricity is going to look like on a very large metal object like this, 15-pound weight right here. This is almost certainly going to turn off the sound on our microphone, but that's fine. We'll deal with that as it happens. Okay, you guys ready for this? Let's turn off those studio lights. Fixing the microphone. Can you read my lips? Oh, hey, cool. He's back. Cool. Sweet. Fantastic. Hey, the snowball is learning. All right, we have a question from the audience.
How much power is in a lightning bolt?
Ooh, how much power is in a lightning bolt? I don't know the exact number off the top of my head, but a very large amount. Remember, we were talking at the beginning of this about the difference between voltage and current and those relationship with power. Lightning bolts are traveling very, very long distances, which means they have incredibly high voltages. And the sheer number of electrons required to go through that amount of air is also very, very high. And so therefore, very high amounts of power. Cool. Yeah, I see we have another question.
What are some of the strongest conductors of electricity?
Ooh. You know, I mentioned this in one of my last live labs. I always say ooh when there's a good question. That was a good question. You guys have probably heard that gold is a good conductor, and that is absolutely true. Gold is used in some of the most important devices that we use in our everyday lives. Your phones undoubtedly have small amounts of gold inside of them that allow electricity to travel from one end to the other. But obviously gold is very expensive, and so we can't use it for all of those kinds of things. And so other types of conductors, such as copper, we use that mostly for our wires, like in our housing and stuff like that. Fantastic. Okay, well, I think this is probably a good place for us to end today. Thank you guys so much for bearing with our technical difficulties.
Yeah.
You can definitely see the power of electricity, and we made a pun earlier about learn the shocking science behind it, and we were definitely shocked by this episode.
Yeah, definitely. Thanks for tuning in with us this week. We're going to be doing the same thing next week. Less electricity involved, so it's going to be way more smooth than this episode.
Hypothetically,
you're right. We're going to be working with dry ice, so if you got excited over this stuff in here, we're going to be exploring a bit more in depth next week with dry ice. It's going to be great.
It's going to be awesome.
Yeah.
So yeah, in the meantime, make sure you subscribe to our YouTube channel and set those reminders. We love seeing people commenting on these, and we like having the back and forth. It makes this whole thing so much more interesting.
Yeah.
But until then, we will be here, and we will make sure that you guys are entertained and educated. So we'll see you next week, Tuesday at 3 p.m. Pacific time. Till then, stay healthy and have fun. Bye, guys.